how we can find out the unknowns. Okay, so two unknowns. Okay. So let us start with our KCL related problems. Okay, so let me draw a simple circuit. Okay, so this is a simple circuit. So let it be 10 volts. This is 2 amps, sorry, 2 ohms, 3 ohms, and 4 ohms. So this is the circuit. So we need to find find the power absorbed by 3 ohm resistor. Okay, let us find the power absorbed by 3 ohm resistor by using KCL. So this is important. Okay, so many methods you can apply. So we'll go with the KCL. Okay, so before that, let us recall what do you mean by KCL. Okay, so what do you mean by KCL here? So sum of incoming currents is equal to sum of outgoing currents. Just I'll give you a small example. This is a node. Let us consider this as a node. Okay, so let it be I1, I2, I3, I4, likewise. Okay, so sum of incoming is equal to sum of outgoing. Sum of incoming currents is equal to sum of outgoing currents in a node at that particular node. Okay, let me clear this. Okay, so before that, what we need to do? Okay, so this is a circuit. It is consisting of a voltage source, 2 ohm resistor, 3 ohms, and 4 ohm resistor respectively, right? So first of all, we need to identify the nodes. So what do you mean by node? The first thing is, so trace the nodes. Okay, so where we can draw the node? So it should be more than uh, minimum two. Okay, more than two or more node branch elements should be there. Okay, so two or more branch elements should be there, or two or more branches should be connected for that particular node. So if suppose, for example, if we consider here, okay, so it is only a single voltage source. So this is a branch consisting of active element. So whatever may be the element, so this is a node, suppose if we consider it, but it is consisting of only one branch, so we cannot consider this as a node. Next we'll move to the another point of contact, I mean point of interconnections. Okay, so where there are multiple connections, if we consider this, I hope you can see this node. So where I have highlighted with a blue dot. Okay, so here if you see, 2 ohms is connected, 3 ohms is connected, 4 ohms is connected. Okay, so more than two are there, I mean at least minimum two are there. Okay, so we can consider this as a node. And coming to this again, so 4 ohm resistor is connected, but again there are no branch elements here. Okay, I hope you can see the screen. Okay, so let me draw the dotted lines. Okay, so since it is a single voltage source, single element, and I cannot consider here as a node. Okay, coming for the next next junction here. So here there are more number of elements, more than two, or minimum two is also fine. Okay, so here I can consider it as a node. Next, coming for this 4 ohm resistor, So here also I can consider, but there is a single element. So here it cannot be considered as a element, branch element. Okay, so that is why a single node. And coming for this interconnection, see at the other end of 3 ohm resistor. So this is also considered as a node, but basically it will be considered as a ground. Okay, so this written part cannot be considered as a node. Okay, so fine. Let me clear this so that it will be easy for you. Okay, so total how many nodes are there? A single node. Actually, it will be two, but let it be the voltage across this particular node is Vx and it will be Vy. So basically, Vy will be 0. Okay, so we no need to highlight here as Vy. Okay, just keep it aside. Okay, so just consider only Vx. Okay, actually the voltage is between two terminals, right? So the other terminal is the ground or the return part. Okay, so hence here there are no elements. Okay, right. So this is how we need to first identify the node. Okay, if we want to solve the problem, so first we need to identify the node. Okay, next, so we have identified the node. So what we require in order to apply the KCL, so we need to identify what are the incoming currents and what are the outgoing currents of that particular branches. So we need to identify the incoming currents and outgoing currents of the branch elements. Okay, so here uh, this I can consider as a branch. Sorry, it is an actually branch. Okay, so please do confirm that my screen is shared. Hope my screen is visible to you. Can someone confirm? Okay, thank you. So screen is visible, right? Okay, so first thing is, so I have identified this is the, I mean, this is one particular direction of current. Let it be I2. So why I am writing it as I2 means, so this is the current flowing through the 2 ohm resistor. I call it as I2 is the current flowing through 2 ohm resistor. Okay, so any direction you may consider, whether it may be outward direction or whether it may be inward direction, and this is another direction, and I call it as I3. What is I3 here? So same, the current flowing through 3 ohm resistor, and this is the direction of current flowing through the 4 ohm resistor, which I can call it as I4. So current flowing through 4 ohm resistor, so that easily we can uh, trace that these currents are represents the current flowing through 2 ohms, 3 ohms and 4 ohms respectively. So I think this information is enough for us. Okay, so first thing is we have identified the node. Okay, so there is a single node for this circuit and we need to know the currents. Okay, so because we need to apply KCL, so we want to know what are the incoming currents and what are the outgoing currents. So anyhow in the circuit they did not mention the direction of current, so I have considered all those currents as outgoing currents. Okay, so that is up to you. So you may consider as something is incoming and something is outgoing, so since we don't know actual direction. Okay, and moreover why we are not bothered about these directions, in the sense, suppose if you find I1 equal to some 2 or 3 amps, suppose for it is example it is 2 amps. So if the value is positive, you have considered one particular direction, so that may be correct. If for example if I1 equal to minus 2 amps, so what the direction you have considered is not accurate. So it may be in opposite direction. So but the value never changes. So that is why we can select any direction if they did not mention the direction of current in that particular branch. Okay. Okay. So what are the things? So I2, I3, I4, and all are outgoing currents. Done. So first thing is we need to apply. Let me change. Apply KCL at node X, where we are calling the voltage as Vx, or you can name that particular node. You can call it as node X or node A something. Okay. So I have considered it as X, and the voltage across that particular node is Vx. Okay. So applying KCL at node X. So as per KCL, incoming currents is equal to outgoing currents is equal to outgoing currents. So what are the incoming currents for node X? So there are no incoming currents. So because I have considered in such a way, right? All are outgoing currents. So you can write incoming currents is equal to 0 and outgoing currents are I2 plus I3 plus I4. Okay. So I rewrite it I2 plus I3 plus I4 equal to 0. So we don't know the values of I2. Okay, let me find one by one. Okay, what is I2 here? So I2 is the current flowing through the 2 ohm resistor. So basically we know the formula. What is the current flowing through a resistor? I equal to V by R, right? So V in the sense voltage across that particular element, and R is the value of that particular resistor. Okay, so what is I2 here? So it is connected between two terminals. So this is considered as, say this is an voltage source and this is the another voltage source here. So it is connected between these two terminals. This 2 ohm resistor is connected between Vx and 10 volts voltage source. So then what we need to write? So I equal to V by R, right? So I2 equal to, so we have to write it as Vx minus 10 by 2. So this is the value of I2, right? Next, what is the value of I3? I3 is, so the voltage across the 3 ohm resistor is Vx. Okay, so then Vx by 3, since the R value is 3. Next, plus, so we have finished this I3 and I2. Let's move to the I4. So what is I4? Current flowing through the 4 ohm resistor. So it is connected between Vx and it is I mean this is considered as 0 already. So actually it will be Vx minus 0 by 4. So you can write it as Vx by 4, which is equal to 0. So as per this equation, that would be equation 1. So this is how we need to frame the equation. So let us solve this. Okay. So Vx into 1 by 2 plus 1 by 3 plus 1 by 4 minus 10 by 2 is equal to 0. So let me just find out this value. So Vx into 1 by 2 plus 1 by 3 plus 1 by 4 equal to 5. So since 2 5s are 10. Alright. So let me solve this. 1 by 2 plus 1 by 3 plus 1 by 4. So we need to find the equivalent of this. 1 by 2 is 0.5. So 1 by 3 is 0.3 and 1 by 4 is 0.25. Right. So let me sum this. So it is 1.08. Right. So Vx into 1.08 equal to 5. 5 divided by 1.08. You may check the answer. Suppose since I am using a virtual calculator here, it is showing it as Vx equal to 4.62 volts. So I found the value is Vx equal to 4.62 volts. Okay. So what they have asked exactly? I mean before that. So what is Vx here? So this is the voltage across this particular node. Okay. So they have asked that to find the power absorbed by the 3 ohm resistor. So this is the 3 ohm resistor. Okay. So what is the power? Let me change the color. So what is the power absorbed by resistor? You may use I square R or V square by R. Any of the formula you may use. So I can just say that, see, since this is the voltage across the 3 ohm resistor, so that is Vx. So you can write it as Vx square by R value is 3. So what is Vx here? 4.62 whole square by 3. So which is equal to, let me check the answer. 4.62 whole square divided by 3. So it is showing as 7.1 watts. Let me use the other formula. So P equal to I square R. So what is the I? Current flowing through the 3 ohm resistor is I3. So what is the value of I3 here? So Vx by 3. So again it remains same, right? So I equal to Vx by 3. So Vx whole square by R. So I think it will be the same formula. Okay. So the value is 7.1 watts. So please check with this answer whether I have done correct or not. The value. Okay, the method is same. Check with the values. Okay. So this is the procedure of finding the parameter, whether it may be the power, whether it may be the voltage, whether it may be the current. Okay. So any of the parameter they ask us to find, and we have to apply the KCL method. So this is a very easy method when compared with the KVL. So earlier what we used to do in the KVL, we need to draw the polarities, we need to consider the direction of current, we have to apply KVL for loop 1 and apply KVL for loop 2 and find the unknowns. So based on those unknowns, we are going to find the particular parameter of that any branch. Okay. So this is one solution. So let me give the another circuit. So in parallel to me, you can also start working on this. Okay, let me go with the other example. So let us consider a voltage source, a resistor, the same, and here I am adding another resistor. Okay, so the value may be 10 volts, 2 ohms, 3 ohms, 4 ohms, and 5 ohms. So let the values are like this. Okay, so find power absorbed by 2 ohm resistor. Already in the earlier session we have covered the model. I mean, so an element which is connected between two loops, right? Let us find the power absorbed by the 2 ohm resistor only. Okay, so applying KCL. Okay, so first thing what we need to do here, to identify the nodes. So by observing the circuit, how many nodes are there here? So here it is two nodes. So let it be node X, so which the where the voltage is Vx, and this is another node, let it be Y, and the voltage across this node is Vy. Okay, because two elements are connected here, so that is why I can consider here as a node. Okay, So once you identify the nodes, then we start applying KCL there. Okay. So before that, let me consider the directions of current, because we require the currents, right? So let it be, this is I2. So since in the circuit they have not given, so I have considered it as all are outgoing currents. This is I3 and this is I4. So when I consider node Y, okay, when I consider node Y, the direction of currents I can consider it as this is I4 and this is I5. Okay, so we'll apply the KCL. So apply KCL at node X. Okay, we need to apply KCL at node X. So what are the incoming currents? So there are no incoming currents. So all are outgoing currents. So the outgoing currents are I2. So where I2 is the current flowing through the 2 ohm resistor, plus I3 where the current is flowing through the 3 ohm resistor, plus I4. So this is the direction. Don't go for node Y. Okay, here two nodes are there. So node X and node Y. Okay, so we have applied for KCL at node X. So look at this direction of current. So I have considered as I4 in outward direction. So hence it will be 0. Okay, so let it be equation 1. So now we need to find out the values of I2, I3 and I4. What is I2? Current flowing through the 2 ohm resistor. Since 2 ohm resistor is connected between node X and 10 volt voltage source, so then it becomes Vx minus 10 by 2. Okay, plus what is I3? So Vx I equal to V by R, right? So voltage across this 3 ohm resistor is Vx. So between these two terminals. Okay, hence it is 0. So we can write it as Vx by 3 plus I4. So what is I4 here? Current flowing through the 4 ohms and it is connected between nodes Vx minus Vy by 4 is equal to 0. So I repeat once again. So the current flowing through 2 ohm resistor is I2, which is connected between node Vx and 10 volts voltage source. Okay, and coming for 3 ohm resistor, since it is connected between Vx and 0 potential here, so hence it becomes Vx by 3. Next, coming for this 4 ohm resistor, which is connected between nodes X and Y. So then we have to write Vx minus Vy by 4 equal to 0. So let me rewrite this equation. Vx into 1 by 2 plus 1 by 3 plus 1 by 4, and what is Vy? Minus 1 by 4 into Vy equal to 5. So based on this equation I have rewritten this. Okay, so let me find Vx. So this is Vx into 1.08 minus Vy into 0.25 equal to 5. So let it be, sorry, let it be highlight here. So let it be equation 1. Okay, next apply KCL at node Y. Okay, so at node Y. So what are the currents for node Y? If you look at this node Y, so all are outgoing currents. So that is I4 plus I5 equal to 0. So I4 and I5 are outgoing currents and there are no incoming currents. So what is the value of I4? The current flowing through the 4 ohm resistor which is connected between nodes Y and X. So then it will become Vy minus Vx by 4 plus what is I5 here? Current flowing through the 5 ohm resistor and which is connected between Vy and 0 here. Okay, so hence it becomes Vy by 5 equal to 0. So further I can write this equation as minus 1 by 4 into Vx plus Vy into 1 by 4 plus 1 by 5 equal to 0. So it is minus 0.25 into Vx plus 1 by 4 is 0.25 and 1 by 5 is 0.2. So this is 0.45 equal to 0. Okay, so let it be equation 2. So I hope you can start using the calculator. So we need to find out two unknowns, that is Vx and Vy. So let me check. So you can go through the previous session how to use the calculator. So just go for finding two unknowns. First thing is go for mode clear, click on equation and we need to find two unknowns. So A1 is 1.08 and B1 is minus 0.25. We should not miss the polarity and C1 is 5. Next coming for A2 it is minus 0.25 and coming for B2 constant it is 0.45 and C2 is 0. So the value is voltage across node X. So which I found Vx equal to 5.31 volts. Please cross check with this value. Next Vy. So Vy equal to 2.95 volts. So these are the two unknowns I have found. Okay. So what they have asked. So find the power absorbed by the 2 ohm resistor. So what is the power absorbed by the 2 ohm resistor? Okay. So P equal to V square by R. So what is the value of V here? V in the sense. So what is the uh, voltage? I mean, so or else you can write it as I square R. Okay. So what is I here? I2. So I2 whole square into R value is 2. So what is I2 here? So it is Vx minus 10 by 2 whole square into 2. So what is Vx here? 5.31 minus 10 whole square into 2. So let me check the value. 5.31 minus 10 divided by 2 and this value into 2.345. So it is 10 point. I have observed this value as 10.99 or approximately 11 watts. Please check with the answer. Okay. So this is the power absorbed by the 2 ohm resistor as per KCL. Okay. So this is the way of finding the solution by using the KCL. So the majority of the thing is that so what are the incoming currents and what are the values of incoming currents. So similarly for node X and node Y. So like this we can go for complex number of circuits like whereas in KVL so maximum we can go for 3 loops. So we can easily calculate 3 loops. If there are more number of loops then the complexity gets increased. Suppose if we go for KCL method, so it will be helpful for us to identify the solutions if there are more number of loops. Okay, so that is the advantage of this KCL. So that's all for today. So let's have the discussions.